Hello, everybody. Welcome. Today, I'd like to showcase a programming language that I've been working on called NM, which I will leave as an undisclosed acronym for now. But this is a project that I've been working on for a long time. This is the culmination of many attempts over a few years to get a working prototype. So, not continuous work and not cumulative work, but I have been thinking about this and working on it for a while. So this attempt, I have gotten pretty far and I want to document it. So what I'm going to show is I'm going to show a few programs that I've written that showcase some basic functionality. So this is a program in my programming language, which is a Lisp. So you can tell by all the parentheses that calculates the factorial of 7. So you can see here I've got a function definition. This is a recursive function that calculates factorial. And then right here, this is a call to the function print fact7. So if I run this, you'll see I get the result 5040, and I can make this smaller, and I get a result of 120 for 5, and I think it goes up to 12 before the 32-bit integer overflows. Yeah, so here's a factorial 12. You can check the math. Um, yeah, but pretty cool. So that's one program that I've written. And here's another program. I like this one called Squares. And what this does is it calculates the squares from 1 to 100. So we have a definition here for a function called square, and then a function called squares that calculates the squares from start to end. And then I go ahead and call it here um, from 1 to 100. So let's run squares. And you can see I printed out a giant list of squares 1, 4, 9, 16, 25, etc. All the way up to 10,000. And once again, we can change this to, if let's say I only want 10 squares. All right, there you go. Here's 10 squares. Um, yeah, but the syntax is a little bit funny. And you can see I've even got this little rainbow extension that turns all my parentheses cool colors so I can keep track of this. Um, but so I'm going to go ahead and teach you a little bit about my programming language. So let's make a new file and let's um, write some programs in NM. So we'll call this tutorial.nm. And of course, you're probably never going to actually write a programming language in here, but I just want to showcase some functionality. So NM is a Lisp, and in Lisp, everything is a list. And so a list is something that is in parentheses, which is why there's so many of them. So I can have a list of items like 2, 3, or something. Um, like, I can have A, B, C, right? This is a list. This is a list that has the items A, B, and C in it. And traditionally, when you have a list in Lisp, the first argument needs to be a function um, or an operator. So in this case, we can use like multiply. So, um, and when you have an argument at the front of the list, it will operate on the preceding items. So if I have a multiplication symbol here, this is going to multiply 3 times 2. And so if I run this program, we get the result of 6. Um, and I can change these around. 3 times 20, that's 60. Boom, 60 right there. And this is cool and all, but let's say I have a more complicated expression. Um, this 20 value I can replace with another list that's going to evaluate to something. So let's do plus 7, 9. So this inner list is another expression that evaluates to adding 7 and 9 together. So 7 plus 9. And this gets me 48, which is 16 times 3, right? 7 plus 9, 16 times 3. That sounds about right. And well, you might be wondering, well, what if I do minus here? This is going to do 7 minus 9. So this will actually be negative 2. And so this will get us -6. So that's a little bit about expressions. Um, let's say, well, I don't want to I don't want to just calculate. I don't want to just do math, or I don't want to just calculate with numbers here. Let's bring some letters into the equation, right? Like it's eighth grade. Let's bring some letters into the equation here. So um, I'm gonna keep that up there. I'm gonna write a new expression down here, and this result here is gonna pull from the bottommost expression. So we should see this value. So let's just make sure this works. Plus 1 is 2. So you see this is now getting from this expression here. So let's create some variables. Let's say I want to write an equation that has times 3x, right? I want to multiply 3 times x. So if I run this, you say we're going to see x is not found. The identifier is not found for x. And so let's identify it. If it's not found, we have to create it. So this is where we're gonna come in here with a let expression. So in a normal programming language, you would do, x equals 5, right? And then you would do 3 times x. So in Lisp, we have to use a let expression. So let's say I'm gonna let x be 5. Okay. Now this doesn't do anything because I have to say, well, let x be 5 in what? What am I letting x be 5 in? And this is where we're going to put another expression, and let's do our times 3x here. So what I'm saying here is let x be 5 in 3 times x. And so if I do this, oh, that's still not found. Let's get rid of the bad code, and let's run it. Now we have 15. Very cool, right? X equals 5, and we multiply 3 times x, and that gets us 15. All right. So, and we can do some more. Let's do something here. Let's square it, right? Times xx. So that's x times x. We're gonna get 5 squared, and that gets us 25, right? And then I can do 89. What's the square of 89? I don't know. There it is right there. 77921, 7,921, right? So all kinds of fun stuff you can do with this programming language. Okay, and now let's get into let's see, one or two more concepts. This is really where the rubber hits the road is with functions. So um, let's say I want to uh, calculate factorial, right? Let's say we're going to write a factorial program. Factorial, if you're not familiar, factorial of x is equal to x times factorial of x minus 1. And this gets you x times x minus 1 times x minus 2, etc. Dot, dot, dot. Yeah, most of you guys are probably familiar with factorial if you're watching this. If you're hiring me or if you're a friend of mine, yeah. So let's write a function to calculate a factorial. So we're going to go with the standard recursive function to do this. So what I want to do is I want to create a function. I'm going to assign it to a variable. So let's assign the variable fact to a function. So in order to do that, we're going to replace this dash with the function I want to define. So to create a function in Lisp, in my language, in Lisp it looks sort of like this. We're going to put func here. And so func is you can think of it as a function that creates a function. It's a built-in operation. And so let me get my parentheses sorted out here. So I'm just going to dump these parentheses on the floor here so I can keep track of these. And so func takes two things. It takes a list of arguments. So let's put x in here. And it takes an expression that we're going to put here. So func of x, and inside this, we're going to put something. So let's just do x times 2 for now as a placeholder. So if I do this, what I've got. Okay, let's sort this out here. So let me do this. So I have let, and then I have let fac be a function of x that returns x times 2. And actually, I made the mistake here of doing x times 2 when this really should be times x2, right? So it's kind of counterintuitive. And what I say is let that function be something in this expression. Let's do fac2. And so what happens if I run this? We get 4. So just to unpack this here a little bit, we have let fac be a function of x that returns the multiply x by 2. That's essentially how you can read this code. And it gets worse. So get ready for that. So right, factorial is not just multiplying x by 2. I could also do x times x here. Of course, that's also going to be 4. Let's put 5 in here. So this is now a function that squares. Okay, so if we want to do factorial, we're going to replace this expression, and I'm going to drop these on the floor once again, and func x, and so in here, I'm going to say if, actually no, I don't need to do that, if, and then I'm going to say equals x1. So if x equals 1, then return x, else we return times x factorial of minus x1. And this gives us 120. So sorry, I just typed that out really fast. And I'm going to explain it. But we have this if statement, right? So this is the very first thing in our function. We have an if statement that says if x equals 1, right? We put the equals at the front. Then x. Else, we have this expression. And remember, that ends with the yellow bracket here. So we're going to multiply x times factorial of x minus 1. This is essentially, I'm going to type it out in a programming language that was made for humans. If x equals 1, then return x. Else, return x times fac of x minus 1. And so when you take this, I'll just match up, here's x equals 1, I'll match that up with this, return x, match that up with this right here, and then x times is this times x, and then factorial of x minus 1 is this thing. X minus 1 is the minus x1, and then fac goes right here. So yeah, without trying to teach you Lisp in this video, that's essentially how we get to factorial. And now we have 5, and I can change this to 9, change it to whatever I want, and that is about it. And so you can see how we can use this concept of, we can use recursion to build up loops, and we can do other stuff. Lisp is known as a functional programming language where we don't actually need loops built into the language. However, there are limitations, like, for example, with my poor implementation, I ran into a Stack Overflow when I tried in this program to compute the squares of up to 10,000. And of course, it's going to be kind of slow, but that is the programming language, and it's definitely pretty cool. I have some ideas in store for what I want to do with this. Obviously, this is not very useful on its own. So anyways, thank you for watching, and hopefully there'll be a follow-up to this, and I'll see you in the next one. Bye.